So this problem, just like the last problem, except for we're given grams of ammonia, and we're asked to find out how many grams of hydrogen we need to produce that many grams of ammonia. So we can't go grams to grams. We have to take grams, find moles, and then once we found moles, then we can find grams of hydrogen. So back to grams. So moles equals grams over molecular weight. So moles of ammonia, right, will equal, we've got 12.91 grams. And we know that the molecular weight is 17.031 grams per mole. So we divide that through to see that we have about 0.758 moles of ammonia. And now that we have moles of ammonia, now we can convert to moles of hydrogen using our balanced chemical equation. And we see from above that every time we make 2 moles of ammonia, we need 3 moles of hydrogen. So to get ammonia to cancel out, every time we have 2 moles of product of ammonia, we have to put in 3 moles of hydrogen. So if we multiply by 1.5 and our ammonia cancels out, we're left with moles of hydrogen, and we see that it's about 1.137 moles of hydrogen. We're not done there. Now we need to convert that to mass of hydrogen, so we'd say that we have 1.137 moles of H2. We don't know the mass of that. We do know that hydrogen weighs 2.01568 grams per mole. Multiply that across, and we should get grams of hydrogen to 4 significant figures, 2.292 grams of hydrogen. All right, so that should be pretty comfortable now, but this last step is going to be the more challenging one because it's a little bit different calculation. So it's asking how many molecules of NH3 are produced for every 6.68 times 10 to the minus 4 grams of hydrogen. So for that, we still have to find moles because we have to go, we can't go grams to grams. So moles equals our grams, 6.68 times 10 to the minus 4 grams of hydrogen divided by our molecular weight, which is 2.01568 grams per mole. To see that we have 3.3 times 10 to the minus 4 moles of hydrogen. And now we need to convert our moles of hydrogen, right, to moles of ammonia before we can do anything else. And so for every 3 moles of hydrogen we put into the reaction, we get 2 moles of ammonia out of the reaction. So multiply by 2/3, and moles of hydrogen cancel, and we get what? About 2.21 times 10 to the minus 4 moles of ammonia. This must have been a 0. And what does that leave us with? Now that we have moles of ammonia, we need to find out how many molecules, right? And so what do we do, or what do we use for that calculation? But we use Avogadro's number. So we have 2.21 times 10 to the minus 4 moles of ammonia. And we know that 1 mole of ammonia equals 6.02 times 10 to the 23rd molecules. Oh, come on. Of ammonia. So multiply across, moles cancel, and we should be left with 1.33 times 10 to the 20th molecules of ammonia. And so we just needed, once we found moles, we needed to take Avogadro's number because we know that 1 mole equals 6.02 times 10 to the 23rd molecules.